So we are going to find some irrational square roots here. Now, what that means is, in this case, we're not going to be able to use our calculator because our calculator is going to give us a decimal approximation. It's going to give us a very, very good decimal approximation, but it will not give us an exact answer. So we are going to get some exact answers for these problems, and we are going to simplify things to the simplest radical form. So this is also called simplifying to the simplest radical form, or finding irrational square roots. Now the calculator decimal approximation is extremely good for doing further calculations. The decimal approximation on the calculator will be very good for checking your work as well, and we'll do that in these problems. But unless there is an instruction that says round your answer to whatever decimal place, you cannot just give me a decimal. That will be wrong. We want exact answers here. So the square root of 216. The strategy for solving this problem will be the same, and I'm trying to write in white. That's pretty funny. The strategy for this problem will be the same strategy that we tried yesterday when we had rational roots. We want to find an irrational root by finding perfect square factors that go into 216. Can anyone think of a perfect square number that will go into 216? Harper? 4. And there's no reason why we can't start with the smaller numbers. So 4 goes into 21 5 times. Carry the 1. 5 goes into 16 4 times. So we have the square root of 4 times the square root of 54, and that is equal to the square root of 216. 54 is not a perfect square, is it? No, it isn't. Is there another number? Is there a factor of 54 that is a perfect square?
Yes.
Is there a factor of 54 that is a perfect square factor? Nick? 9. So 9 goes into 54. So the square root of 54 can be broken into the square root of 9 times the square root of 6. Now, I know the square root of 9 is 3, so I'll just go ahead and drop that down. I know the square root of 4 is 2, so we have 2 times 3 times, now here's where things get a little bit different. The square root of 6. Does 6 have any perfect square factors? No, of course it doesn't. So we cannot reduce that any further. So since we can't reduce the square root of 6 any further, we're just kind of stuck with it. So the square root of 216 is going to be equal to 2 times 3 times the square root of 6.
6 times 3.
Oh, so I can multiply the whole numbers together, can't I? So 2 times 6 is 6 times the 2 times 3 is 6, thank you. 2 times 3 is 6 times the square root of 6.
So you don't have to put the multiplication.
And so, no, because when you have a number next to a bracket, in this case, it means multiply. So we end up with a simplified answer of 6 times the square root of 6, and we can't go any further. But at this point, we need to show that these are equivalent statements. It would be unfortunate for us to just move on. So we have our calculator here, and I'm just going to double check. I'm going to do the square root of 216, and that's going to be in white, which is really, really helpful. There we go. All right. And then I'm also going to find the answer of this on the calculator, and if everything has gone right, we will get the exact same decimal approximation. Let's see if it worked. So we have the square root of 6 times 6. Look at that, folks.
Oh my god.
Oh my gosh.
Way, Jose.
It worked. They are equivalent. Okay.
I did it on my calculator.
So I can see and hear that you are as excited about this as I am. All right. So moving on to our next problem.
Yes.
So now we have 3 times the square root of 125. Is there any reason why we can't start with a number outside the bracket? No, absolutely not. It just means we need to remember that we're going to have to multiply the square root of 125 by 3. All right, Liam, so what goes into 125 that is a perfect square factor? That's funny because Liam now has a voice scarily similar to Sophie. 25. So the square root of 125 is equal to the square root of 25 times the square root of 5. And we still have this 3. So we have 3 times, what's the square root of 25?
5.
5.
Oh, this one was actually an easier one.
Yeah, this is not too bad. Now, the square root of 5. Does 5 have any perfect square factors?
No way, Jose.
No, it doesn't. It definitely does not. So we're just kind of stuck with this like, I won't even go there. So 3 times 5 is? 15. And we have square root of 5. So our answer is 15 times the square root of 5. And that's our answer. We can't take it down any further. And just to double check, because that's what we're doing here, let's find our decimal approximation and see if it works out. So we have the square root of 125 times 3. All right, so we'll save that up here. And then let's take our answer. So we have the square root of 5 times 15. And does it work? Yeah, they are equivalent.
Exactly the same.
Okay. So I know we're doing this correctly. For this next problem, I probably will not do the decimal approximations. You get the idea. This process works. So we have this negative square root of 1,920. So what goes into 1,920? That's a perfect square factor. We can start small, and there's nothing wrong with starting small.
Perhaps a 4.
We definitely know a 4 because the last 2 digits are divisible by 4, so the whole thing
Oh, that's
is
how you
divisible.
said?
Yeah.
Oh, good to know.
So you have the square root of 4 times the square root of 4 goes into 19 4 times. The remainder of 3, so that's 8. All right. So then we have 400, the square root of 480. What goes into 480 that is a perfect square factor? Ashby?
10. No, that's not.
Yeah, no, 10's not. 4. Okay, we can do the 4 thing again. Absolutely. So we have 4 times the square root of, 4 goes into 4 once, 4 goes into 8 twice. So what goes into 120? That is a perfect square factor.
4.
4.
Wow.
Sure, we can break this down further.
Oh, we love our
So,
fours.
yep, you gotta love 4. There's nothing wrong with doing this with the 4s. So times the square root of 30. Now here's the tricky thing. 30. 30 has a bunch of factors, right?
Oh, gosh.
It has a factor of 2, 15, then another
Five.
factor pair of 5 and 6. Are any of those perfect squares?
Oh, no.
They are not. So we are pretty much stuck at this point. So what is the square root of 4?
2.
So we have that one here. What's the square root of 4? What's the square root of 4?
2.
Times the square root of 30. So this reduces to 8, because 2 times 2 times 2 is 8, times the square root of 30. And then we are looking for the negative square root, so this must be negative.
Oh, that was easy. Wait, where do you put the number?
You just stick it in front of it. So this, again, is called finding the answer in simplest radical form. It is nothing different from what you've done earlier in math. It's just that you're ending up with an answer that has a square root in it.